Hi, this is Bruce from Animated Prop Systems, and this is part 2 of our video on the Butler-on-a-track prop, which is a prop we made to go in the second story window of a house, and every once in a while it would roll out in front of the window and look down at the people on the street and go through his movements, and then after he did that he would roll back out of sight behind the wall. Now, in the first part of the video, I talked about how the track and the base were constructed, and in this part of the video, we're just going to talk about the torso, which is a complete self-contained unit. It's got its own power supply and its own controller. But before I talk about that, let me show you how we did the mechanical parts of the torso. Okay, we're back behind the prop here, and I'm going to lift up the jacket and the shirt, which is something I just got at the local Goodwill store, and I'm going to clip this up here so it doesn't get in our way. Now, mechanically you can see that the torso is constructed of a couple pieces, and the main one is this U-shaped frame made out of wood right here. And that frame is attached to a large Lazy Susan bearing, and the side of that U-shaped frame is attached to our servo here, which allows us to rotate the torso about 45 degrees. Now, inside the U-shaped frame is the actual torso, which is a box made out of wood with a 1/4-inch bolt that goes all the way through to act as our bearing. And this servo here is attached to the torso part, which allows us to make the torso lean forward like he's wanting to take a closer look at something outside of the window. Now, when we built this entire thing with the weight of the head and the lantern and the arm and the clothes as well, we realized that the thing was so heavy that it wanted to tip over. So we added this secondary box here in the bottom, and we put bricks in it to act as a counterweight. And that worked out really well because now the thing is so well balanced that it doesn't even need to be screwed down to the base. And part of that is because it's so heavy. Okay, now the actual head came from a Halloween candy dish prop that was this tray about 18 inches in diameter. It had that head in the center of the tray, and when you put candy in there and when a kid put his hand in the tray, there was a light sensor, and the prop's eyes would move back and forth, and I think he made some sound. So in this prop, he doesn't make any sound, but the eye movement was really great, so I wanted to use this prop. Now, the eyes move back and forth, and the eyelids actually close. So what I did was take the mask apart, and I put a servo in to make the eyes go back and forth, and I utilized the small DC motor that was already in there to make the eyelids open and shut. Okay, now we're back behind the prop again, and you can see that I've mounted the mask itself on this block of wood, which has a bolt and a bearing that goes through it that allows me to turn the head side to side. And then I've got a servo mounted inside the head that allows me to tilt the head forward and back. And I also have a servo inside that makes the eyes go back and forth. And as I mentioned, there's a DC motor that came with the actual mask that makes the eyelids go up and down. Okay, as far as the controller is concerned, we've got 4 parts here. We've got a 5-volt, 5-amp power supply that powers all the servo motors, the DC motor for the eyelids, and also an LED for the lamp. Now, this is our controller, which is based on a PIC microcontroller that I created myself, but you could easily swap this out for an Arduino. And then we've got a servo controller that was made by a company called Devintech, and the PIC communicates to the servo controller via I2C, which is a 2-wire interface. And if you're interested, the Arduino also supports an I2C interface, so you could use the same board if you wanted to. And then this is just a simple motor controller kit that we use to control the DC motor for the eyelids. Okay, now I've put the coat back down and I've turned the prop on. And before I show you what happens, I wanted to point out that we have a sensor on the rolling base that's a photo sensor, just exactly like the sensors we used on the track. in order for the base to determine whether it's at one end of the track or the other. So we've mounted this photo sensor here, and that goes to the PIC microcontroller, and when it gets to the end of the track, this piece of metal breaks the beam of our photo sensor, and that's what tells the microcontroller to start going through its movements. So once it gets to this point, the torso will start going through its movements, and it tilts its head, and it blinks its eyes, and leans forward to try and give the illusion that it's seen something down on the street that it wants to take a closer look at. And it blinks a couple more times, and again, keep in mind that this is in a second-story window of a house, so it's looking down on the street. And then after it completes its series of movements here, which takes about 35 seconds, it simply stops, and then the base controller, which knows that it needs to wait 35 seconds, is going to move the prop out of the way. And that's how the torso for our Butler works. Okay, so now I've got the prop going, and I've got the lights turned down, and I've got this small can light pointing up in his stop position, so as people look out the window, this is what they see. And you can see that that light creates very creepy but realistic shadows on his face, and it's a very realistic prop. So this is how the Butler-on-a-track prop works.